Mr. Investor, today we're going to be talking about Nano Dimensions. Is Nano Dimensions worth $100 a share? And make sure you're subscribed so you don't miss out on any future content. Always remember, I'm not a financial advisor, this is not financial advice, please do your own research, and this is for entertainment purposes only. We're going to be talking about all the uses for printing circuit boards, and how Nano Dimensions can make money from all these different industries. So 3D printing is used on a daily basis in society. So we're going to discuss all the different companies, we're going to discuss how it's used in different industries, and how Nano Dimensions can benefit from this. So why do we use 3D printing in consumer electronics? So consumers have started to expect periodic releases of ever more advanced electronics, from smartphones to smartphone systems to new wearables, including like the Apple Watch. Lots of these products require evaluation and testing before they hit the market. So although additive manufacturing is basically used in more complex electronics that aren't usually found in the consumer space, the 3D printing in the development stage provides significant benefits in terms of prototyping and preparing for full-scale manufacturing. We can also see that additive manufacturing is going to be used in the automotive electronics. And with the big push towards EV vehicles, we can see that Nano Dimensions has a niche within this market too. So driverless cars are coming. One of the most important things as well is vehicle data collection. And in 2016, McKinsey released a report that stated data gathered from modern vehicles on a global scale will be worth 450 to 750 billion by 2030. This data can be used to measure feature use, improve navigation systems, improve safety, and driver assist systems. They can also monitor their fleets, and you can better predict when your fleet requires maintenance. So modern cars already use a lot of technology, including sensors and technology to detect and respond to external stimuli for control and monitoring of everything from engine timing to oil pressure. So if we look into the future, we can see that embedding networking, sensing, and smart device capabilities directly into the structure of a vehicle reduces the number of fabrication and manufacturing steps. This can be true not just for a multi-layer printed circuit board, but also for overall components. So additive manufacturing also cuts the time needed for prototyping and testing the new automotive components, speeding up the development cycle and decreasing the time to market. And when autonomous vehicles become, the norm, they're going to require a communication network to coordinate their speed, positioning, and heading, as well as the data gathered from networks of sensors on each vehicle. Nano Dimension and the creation of these high-performance electrical components and devices, printed circuit boards can be used in the autonomous driving industry. There are also automotive PCB manufacturers out there that are manufacturing for LiDAR technology and autonomous vehicles. So Nano Dimension was stating no matter what the industry is, prototyping and production of electronics are more efficient and cost-effective when you have access to a precision in-house additive manufacturing system, aka their Dragonfly Pro. And although additive manufacturing systems are not the holy grail of cost reduction, they still do provide significant benefits in the areas of new product introduction, prototyping, supply chain management, and reduced part complexity. So there's loads of major players that are taking advantage of this, including BMW, Ford, and with the race for EVs to be on the road and autonomous systems, Nano Dimensions products can play a key part in this industry. When we're looking at the Internet of Things as well, the IoT, you can see it brings the power of the internet, data processing, and analytics to the real world of physical objects. For consumers, this means interacting with the global information network without the intermediary of a keyboard or screen. So many of our everyday objects and appliances can take instructions from that network, and we don't have to get involved. Minimal human intervention. So Nano Dimensions had a pretty tough year with 2020 and COVID and everything, and they said that, in the near term and the midterm, they expect a slowdown effect, but it's going to be acting like a slingshot once COVID-19 starts to phase out. So we come back to printed circuit boards, and I wanted to show you guys that printed circuit boards are used in so many different industries in many different products, and Nano Dimensions can influence this by speeding up production. So in terms of the production cycle, we know that they'll be able to print prototypes in just a few hours, which means faster time to market, freedom to innovate, and you can also protect your intellectual property in-house. When Nano Dimensions finally sells these dragonflies, they're not just going to be making money from the sale, but ultimately they're going to be making money from their Agsite ink, their patented silver Agsite ink. So I went back in time to August 2016. I looked at the old presentations, and I can see that Nano Dimension was expressing that electric circuit boards, printed circuit boards are everywhere. So this means that they can have growth in so many different industries and markets. Here you can see consumer of electronics and Internet of Things, massive industry. We've got the automotive and industrial industry. So we're talking about autonomous vehicles, autonomous fleets, talking about telecom. Oh, baby, we're talking about iPhones, baby. A lot of innovation in medical devices are also using PCBs, as well as military, defense, aviation, and aerospace. So first of all, let's start with something that everybody knows. Everybody knows iPhone. Everybody knows Apple. iPhone uses a printed circuit board with a 64-bit architecture. Furthermore, the motion coprocessor allows the iPhone to deliver faster speeds, amazing graphics, and functionality. PCB is the physical component in the devices that run electronically. And you can see here in 2018, Apple sold more than 217 million iPhones, 217 million printed circuit boards. And in terms of consumer electronics, we can see here on Statista.com that they're forecasting that the consumer electronics industry, we're talking about 5G networks coming out, we're talking about 5G smartphones, smart devices, TV, radio, multimedia, TV peripheral devices, drones, telephony, and computing is going to be worth 1.1 trillion by 2025. We've even got universities working back in 2018 to create 3D printed smart glass. And some of the innovation that I've seen recently is with this company coming up called View. So View actually uses high performance electronical components to actually make smart glass. And with this smart glass, it has so many features.
The smart window controls heat and glare, eliminates blinds and shades, and provides view and natural light all the time. Because we have a highly connected system, we're able to bring a whole host of smart building applications. For example, this video you're watching is coming to you through the View Smart Display, which is a high-definition display installed right into the window. Also on this platform, we have a sensor array that has a number of environmental sensors. And these can be used in order to control the environment precisely for the health and wellness of the people. These new applications transform buildings into living spaces that help us engage, interact, and communicate with each other.
Even companies like View are using smart electronic systems in order to innovate. So let's talk about the military's uses for 3D printing, specifically printed circuit boards. So here we can see printed circuit boards are fundamental to the operation of military navigation, guidance, control, electronic warfare, missiles, and surveillance and communications equipment. The importance of printed circuit boards to all military missions, legacy, current, and future, cannot be overstated. However, the Department of Defense found that there was a problem with acquiring printed circuit boards. This is because they had unique requirements. So for example, here we can see electronics in some of the vehicles. Military trucks can be very different from commercial trucks, but the printed circuit board that controls the fuel injectors in both types of vehicles can be exactly the same. So in terms of printed circuit boards, they needed to be robust for aerospace and military, and they cannot fail.
So that would be the prime aim of them electronics, is longevity and zero failure. To improve reliability on PCBs, you really need to start at the PCB fabrication and design itself. So obviously the first thing the designer needs to design the board to be reliable.
So I wanted to understand the basics of military-grade circuit boards, and printed circuit boards are often used in military applications. Those that are used in these rough environments will need to be highly reliable. They will often have to function in harsh conditions. So a typical printed circuit board will not be exposed to environments that would damage it. However, with military vehicles and military uses, the PCBs may come into regular contact with contaminants, chemicals, and extreme temperatures. Therefore, these printed circuit boards need to be military-grade circuit boards that meet or exceed the specifications of requirements put forth by the military. So what's really good is they can continually process and create prototypes for these circuit boards with the Dragonfly, and they can do it within hours. Some of the applications of the high quality printed circuit boards used today are unmanned vehicles, robotic systems, defense navigation systems, communication systems, computers used in the fields, mortars and artillery, satellite subsystems, and base camp protection and security. So there's a wide range of uses for the military to have these printed circuit boards. It can help them with electronic warfare and lots of their weapon systems. Let's take a look at both the aerospace industry using printed circuit boards. They can use it for satellite equipment, they can use it for digital signal microwave processing systems, they can use it for central air data computers, ground station applications, passive detection systems, a whole load of systems. So the Department of Defense was urged to buy only US and Canadian made electronic printed circuit board technology, but when they saw Nano Dimensions, Dragonfly, and seen what it can do for their industry, they decided to buy it. So when we're taking a look at the Nano Dimension Dragonfly LDM, we can see the price ranges from $100,000 to $250,000. But overall, they'll be making real big money from their silver Agsite 3D printing ink. There's also electronic systems in so many different vehicles. There's 73,000 tanks in the world, and the latest, most innovative tanks can be using printed circuit boards to actually navigate. Printed circuit boards can be used in the audio and video audio equipment found in cars, the car stereo and video displays, make use of this board to connect electrical components to make sure it will function as anticipated. They can also be used for global positioning systems or GPS. Autonomous vehicles, baby. In terms of other vehicles as well, we can see in the foreseeable future, we're looking at drones and UAVs. So UAVs, unmanned aerial vehicles, have become a way of life. These devices encompass many different industries and applications, including aerial topography, geologic surveying, arts and entertainment, military, surveillance, athletics. These drones are allowing a different perspective towards life, and they all need printed circuit boards. In terms of the global drone market itself, we can see here that in 2018, 276,600 drones were sold. So that commercial drone market is expected to grow at a compounded annual growth rate of 56.5%. And even Goldman Sachs was stating that the market size for drones is going to increase significantly. Although 70% of the figure will be for military activities and uses, Goldman Sachs states that they believe commercial business will represent the fastest growth opportunity for drones. So we know drones need this printed circuit boards, but they've also got sensors. Drones also have a lot of smart electrical devices within that are going to monitor, the battery. And moving on, this Globe Newswire article was stating that the global autonomous driverless car market projections from 2020 to 2025, they're expecting a compounded annual growth rate of 18% per year. All of these autonomous vehicles are going to be using technologies like radar, LiDAR, GPS, computer vision, and advanced control systems. The autonomous car market is estimated to reach $60 billion per year by the year 2030. So with the current share price of Nano Dimensions, the only thing I can see stagnating their growth is when they keep diluting shares and they make investors lose hope. It's good for them to raise capital, but a lot of people get upset when they see shares being diluted. And this has happened several times over the last year. In terms of competitors into the market, I've been looking at some of the competitors, but as ARK Invest had mentioned, nobody is doing printed circuit boards and focusing on electrical components like they are. Some are just starting to touch on 3D printed electronics, but they're also focusing on other industries. Some companies are focusing on bioprinting as well, so they're looking to produce, human tissue and organs. For example, Felix Printers is working on 3D bioprinters, and they're also working on 3D printers for the food industry. So as we can see, lots of innovation is going to be coming regarding 3D printing human tissue. There are also ways that medical devices can also benefit from Nano Dimensions. So I was a student nurse and I was looking at the pricing of some of these vital monitors. So just for you to monitor the heart rate, saturation of your patients. And as we can see here, Nano Dimensions is stating there's groundbreaking innovation with regards to 3D printing, wearable sensors that can monitor all vital parameters. So basically you can 3D print this creation, and it will be compact, it will be batteryless, it will be non-invasive, it will be a wearable sensor that can monitor a human's vital signs both biochemically and physiologically. In terms of some organs and the way they work, are we going to be using 3D printed circuit boards to actually control some of these 3D printed organs? So we all know that all of these industries are booming, and if we look at all the markets across, we can see that they're going to continue to grow. Some people believe that the consumer electronics market is going to reach into the trillions and trillions in years to come. And Nano Dimensions and the ability to use high performance nano inks for printed electronics are going to be innovating and helping speed up the process for a lot of these companies in these growing industries. So right now we're looking at Nano Dimensions stock, and in the after hours it's gone up 3% after taking a juicy dip. People are saying as of now it's quite overvalued, and Nano Dimensions' current price does not justify what they've achieved so far. But for me, looking at Nano Dimensions, I see them as a future innovator. We just have to be patient. We have to see what they're producing, who they're working with. As of now, we can see that COVID has completely shut down their sales for this year, and also the sales that they're predicting for 2021. But in the future years to come, who knows? Can Nano Dimension fulfill their full potential? I believe so. Mr. Investor, thank you very much for watching. It's been a really long presentation. Please hit me up with a like and subscribe. I've put a lot of effort into this video, and drop me some comments down below. Thank you very much for watching. Mr. Investor, over and out.